Okay, now we're getting into definite integrals. So now we have numbers. So we are going to be able to find an actual answer for this, but we're still going to apply the substitution method. And I'm going to show you the way the book showed you because I do think it's smart, and I'll show you what I mean by that. So if we're going from 0 to 4, first we want to let u equal... Oh, this is the same problem we already did on question number 2. Do you guys see how this is the same problem? So I'm going to go right here. This 1/3 u to the 3/2. That's kind of where we were led down. So 1/3 u to the 3/2. Or if we substituted back in, this one's not that hard to substitute back in. And you don't do the plus c anymore because we're going to have actual numbers to plug in. But let me show you the way the book teaches. This represents x going from 0 to 4. But if you want to stop at this point right here, if when x equals 0, oh sorry, I shouldn't erase that. So if u is 2x plus 1, when x is 0, 2 times 0 plus 1, u is 1. And when x is 4, 2 times 4 plus 1, u is 9. So what you can do is you can evaluate this function right here. Remember, if you evaluate it, but since this is u's, we would use 1 and 9. But if you evaluated this function, like you go a step further, you would evaluate it at 0 and 4. Well, it's pretty easy to plug 0 and 4 into this, but you're going to see, like when we get to a different example, it's kind of annoying to put it back in terms of x and then go from 0 to 4. It's kind of easier just to say, hey, we just know it's from u from 1 to 9. So now we're going to do the fundamental theorem of calculus like we did last week. So it'd be f of 9 minus f of 1. So if we plug 9 into this, we're going to get 1/3 of 9 to the 3/2 minus 1/3 of 1 to the 3/2. Okay, and so this would be the square root of 9 is 3, and then 3 to the 3rd is 27. A third of 27 is 9. You can type it in your calculator. 1 to the any power is 1, so it's 9 minus a third, so it's 8 2/3. So to check our answer, I've typed this into Desmos, and you guys see it's 8.6 repeating. This is what the function looks like. If we shaded this function, we would shade from 1 to 4, and we would shade everything straight down to the x-axis. Okay, it would have led to the same thing as plugging in 0 and 4 into your x function. So, but I kind of like what they do here because you can stop one time sooner. We're going to skip 7, and we're going to go to number 8, and we're going to let u equal the natural log of x. This is just an x, and this is just an x, so it wouldn't really accomplish much to let u equal x, because then it'd just be like kind of the same problem again. So we're going to let u equal the natural log of x. So du over dx equals, so the derivative of natural log, you guys remember it is 1 over x. Okay, that's going to help us, because isn't this a 1 over x right here? Okay, so I could like kind of rewrite the original problem as 1 over x times natural log of x dx. Does that make sense? This x you could write as 1 over x out front. So now if we would get du by itself, it's 1 over x times dx. Okay, we like this. We have a 1 over x and we have a dx. We're ready to go ahead and plug in. So we are leaving, let's see here. If I want to plug this in, yeah, we can. So when x equals 1, what does u equal? And when x equals e, what does u equal? So when x equals 1, the natural log of 1 is just 0. And when x equals e, the natural log of e is 1. So now when I'm going to plug in the u, I'm going to, instead of writing 1 and e, I'm going to write 0 and 1. Yes. Okay, let's go ahead and sub everything in. This 1x and dx gets replaced with du. The natural log of x gets subbed in with just u. So u times d of u. Okay, well this is easy. What is the integral of u? Would be u squared, but we'd have to put a 1/2 because 1/2 times u squared as a derivative gets you back to u. And that is the integration. So this, because it has a du, that's the integration. But now we're going to evaluate this at 0 and 1. So if we plug in f of 1 minus f of 0, you probably can do this in your head. If you plug a 1 here, 1 squared times 1/2 is 1/2 minus 0. So our answer is 1/2. And you are finished. Okay, I worked on this one like 4 times last night before I figured it out, but I just had a little error with my derivative, and that's what screwed everything up. So let's let u equal 1 over x, and that also is written as x to the negative 1. So what is the derivative of x to the negative 1? You would bring the negative 1 in front, and then the exponent becomes 1 smaller. I'm going to get du by itself. Times x to the negative 2 times dx. Okay, just like last problem, x to the 2 in the denominator is the same thing as, I'll wait and do that in a second. Same thing, yeah, I'll leave this alone. It's the same thing as x to the negative 2, like I can kind of just can write that out front, times e to the 1 over x times dx. Okay, and let's also not forget to plug in our numbers. So instead of using 1 and 2, that's what you use if you're using x, but if we're using u, let's find the value of that. So when x equals 1, u equals blank. When x equals 2, u equals blank. So if u is 1 over x, this is going to be 1 over 1, which is 1. And then if x is 2, this is going to be a 0.5. Now, this is kind of backwards than normal. This is your bottom number, the 1, and the top number is the 0.5. And we'll see how that's affected here. I think we're ready to sub everything in. The only thing extra I have in this is the negative 1. I'm going to put the negative 1 out front. This x to the negative 2 and dx equals du. And then what does e to the 1 over x equal? That's e to the u. So we just subbed everything in. Let's just say du, right? Now we're ready to take the integration of this. I'm going to keep my negative 1 out front. I'm going to put this in brackets because I'm going to take, this is easy. The integral of e to the u is e to the u. Okay? But we want to evaluate this as at 1 and 0.5. And here's how you can kind of show that work. You can show it like distributive property. It's going to be negative 1 of f of 0.5 minus f of 1. So negative 1 times, okay, what is e to the 0.5 power? I mean, who knows? Look it up on your calculator, right? So you're going to do e to the 0.5 minus e to the 1. Okay? And then when you type that in a calculator, you're going to get, let's remember, if you're rounding your errors, put squiggly equals, is roughly negative 1.0696, which that's just going to turn positive. I'm going to show you a picture of what the function looks like. And I checked on Desmos. So this is what the original function, this function, looks like. And then if you had to shade it, you would shade it from 1 to 2. Because like if you ever want to draw the graph, you go back to the original function just to kind of check your answers look like they make sense. All right, for this one, instead of doing like where we found out our u answers, I'm going to show you that you can just leave them with x's as long as you turn your final answer back into an x, just so you kind of see that, and maybe you'll discover which one you like better. So I kind of did the scratch work at the side. U is going to be sine of x, so I took the derivative of sine is just cosine, and then I got du by itself. So this is nice because we have our cosine x here and we have our dx here that we can sub. Okay, we're going to sub in where we see sine of x, we're going to sub in a u. So let's go ahead and rewrite this problem. I'm not going to write the 0 right now because it's not true that it's 0 to pi over 2 if we're using u, but I'll just kind of get back to that in a second. I'll just put like hashtags, like those are different numbers. Okay, so we don't have anything extra to pull out front. This just becomes our du. So this cosine and this dx got replaced by du. So all we have left is sine of x, which is just sine of u. Okay. Now, what's the integration of sine? That would be negative cosine. Negative cosine u okay? Now I'm going to sub back in my u as sine of x. So negative cosine of sine of x, and we want to evaluate that from 0 to pi over 2. So this step, like, why did we do it this way now? I thought it was kind of more of a pain to like have to plug in u here and do the 0 and pi over 2, where it was really easy just to kind of like put the sine of x back in. So then, I mean, really you can just kind of plug this in. The only place in x that you're going to plug this in is pi over 2 and 0. So it'd be negative cosine of sine of pi over 2 minus negative cosine of sine of 0. So if you think back like to the sine graph, sine at pi over 2 is just equal to 1. So it's going to be negative cosine of 1. This is going to turn negative negative plus. Sine of 0 is just 0. Cosine of 0. And then you're going to round your answer here. It's about 0.4597. Make sure if you guys are doing sine or cosine stuff in your calculator, remember to put in radian mode. All right, example 11. And we're almost done. Hallelujah. All right. Ooh, this one's fun. It looks scary, but it really isn't. We're going to let u equal this, x minus 1 squared, which we know, and we FOIL that, is going to be x squared minus 2x plus 1. So the reason we do that is because it's easier to take the derivative in terms of x. So that become 2x minus 2. And if we're going to get du by itself, and I'm also going to factor out a 2, maybe you'll see why. See how we have an x minus 1 in our problem, and we have a dx in our problem. But we don't really want this 2. So like we did earlier, dividing by 2 is the same as multiplying by 1/2. So this is going to sub in right here. And what are we subbing in for e? This is equal to u. Okay, and let's also do when x is 0, u equals what? So if x is 0, you just plug in a 0 right here. 0 minus 0 plus 1. And then when x is 2, u would be 2 squared, which is 4, minus 4 plus 1. Okay, we probably should just be able to stop right here. You probably should know the answer to this, but if you don't, I'm going to keep on going. But if you think about what this means, you should know the answer, but we'll kind of show our work here. So right now I'm going to plug everything in for u. So I'm going to put the ones here because we're going to have everything in terms of u. So this x minus 1 and dx became just my du. I have my half out front, and then this is now e to the u. The integral of e to the u, du, is just e to the u, and I want to evaluate that in 1 and 1. And I'm going to multiply my answer by 1/2. Do you guys see what's going to happen? We're going to have 1/2 times e to the 1 minus e to the 1. Well, that's 0. So you're going to have a half times 0, so it's just 0. All right, so take 2 pictures of your notes and send them to me in Schoology.